Okay. Here we go. We are recording. Okay. P1, T1. I'm sorry, P9, T1, P9, T2. All right. So as you can see, this is a digest of your plasmid DNA. A literal cutting, a digest, a breaking of your plasmid DNA. When we do this, we're going to cut your plasmid DNA in two places. You can see right here and right here. The enzyme is called PVU2. It's discovered from bacteria, and it cuts wherever it sees CAG, CTG. And when it cuts the plasmid, it leaves an extra 500, I'm rounding, and an extra 200 base pairs, I'm rounding, for a total of extra 700 base pairs. It leaves that attached to the insert. So the insert has an extra 700 base pairs. We have to leave that 700 because we don't know the insert. We just know the plasmid, and we know the sequence of the plasmid. And PVU2 cuts at this specific sequence of CAG, CTG. And we know that sequence, CAG, CTG, is on the plasmid. Well, Rutgers knows it. That's why they gave me this. So we know it, and we're going to cut it out that way. We're going to make two tubes, a cut and an uncut, or a U and a D. The gel says uncut cut. We also call it uncut U, or undigested, and a D is digested or cut. Uncut and digest. Same thing as uncut and cut. All right, so let's do it. Let us do it. That's what's happening here. It starts with our D tubes first. This is P9T1. This is P9T8, our D tubes. I'm going to open up all these tubes. Oh, incidentally, they say D on them. D for digest. I'm going to open up all these D tubes. They say D for digest. And I'm going to put in this, something I just made a few minutes ago. It's the enzyme. PVU2. This is the enzyme solution. But I can't just put pure enzyme in. I have to put enzyme, water, and salt buffer. Don't worry about the amounts. Just know what's happening. Enzyme, water, and salt buffer. The enzyme's the enzyme. It cuts at CAG, CTG. The water is water. And the buffer is a salt solution that keeps the enzyme folded and happy. I just put that in this called a master mix tube. Master mix. I put a red label on it so I know that that's what it is. I'm going to put 10 new tip, dialed to 10 of my mix in all of these. Nothing's in these tubes, so I can use the same tip over and over again. Here we go. It's a little redundant here. 10, P1, T2, T3, T4, T5, T6, T7, and T8. Nice. This is done now. The master mix is done. Okay, so now I have, get rid of that tip. So now I have all of the D tubes for all the tables with the water, enzyme, and buffer. That's the master mix of the enzyme. Now let's put some DNA in there. Let's give it some DNA to digest. Now my DNA is in this box, and I know it's in this box. Let me stop presenting here. Actually, let me share this real fast. I know my positions for period 9 are positions 16, 17, 18, 19, 20, 21, 22, 23. So starting at 16 to 23. 16 to 23. 16 to 23. I'm going to stop presenting so you could see a bigger screen. All right, is that better, guys? You can see the full screen? All right, good. So 16, here we go. 16, 17, 18, 19, 20, 21. $22, $23. Why does that seem wrong? Why does that seem wrong? P9, that's P12. Yeah, we did something wrong there. Hold on a second. We did something wrong. Let's check that screen again. Record keeping is important. Let's see what we did here. Oh, that's not the row, Dodo Jones. It's 13. I was looking at the row in Excel. So very important to check our data here. Okay, 13 through 20. 13 through 20. Okay. So important to check our data. If you look at that spreadsheet, it's 13 through 20. All right, so let's go back with these things. $20, $19, $18, $17, $16, $15, $14, $13. These should all be P9. Yep, P9, 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 and P9. Woo! Record keeping is so important. All right, let's put these over here. Okay, so now let's put our DNA from our yellow tube into that D tube so it can digest. We're gonna do another 10. I gotta change tips this time because I'm going from DNA to DNA. All right, here we go. You know what? I might as well just put them. I can't do that. All right, you know what? I'll close these while I fill them. They'll tell me. DNA on the side. Close. This is going to be a little redundant again. 14. DNA on the side. I'm putting it on the side of the tube. Let's do 15. Close. I'm putting it on the side of the tube. I'm not mixing them. That's okay. I'll show you how I mix them in a minute. Close that up. Oh, hello. Hello. Close. Put that in. Close. And the last one. Oh, new tip. There we go. All right. So now we have let me show you what I have. Bring these to the incubator. Okay. Field trip. You guys can come over or you can watch from there, whatever you want to do. So here we have the D tubes. I'm going to put these D tubes because they're all splattered in the centrifuge. They're all splattered. You know, I put the drop of DNA, the 10 of DNA on the side for your mini preps, and I put the master mix. So I'm going to spin them down for like 5 seconds. This is called a pulse spin. And this will bring the water, this will bring the master mix of the enzyme mixture plus the DNA together and marry them. And look, you can see now they're all together. Let me get a rack. Okay. Let's go in order here. T2, T4, T8, T1, T3, I hope. Am I writing? T5, T6, and T7. Uh-oh. Here we go. All right, so let's put these in the IncuShaker for 10 minutes. We're going to swirl them and incubate them at body temp again. This enzyme, like a lot of enzymes, does like body temperature. So this is going to cut at 37C. 10 minutes. It's 11:35. We'll come back at 11:45. While that's cooking for 10 minutes, let's make our U-tubes. U-tubes. The U-tubes, U stands for uncut. Undigested, same thing, uncut. And they're labeled already, P1T8. So I'm gonna go like this. This is P1, doesn't matter actually, P1T1. And this is P1T8. That's 20, that's 13. All right. So the U-tube. The U-tube is much easier because there's nothing to cut. It's just DNA and water and some loading dye. So I'm gonna open up all of my U's, uncut. Dial my pipetter to 10, it's already dialed. Actually, let me just check. Let me see if it's 10 of water or 8 of water. I think it's 8 of water. No, it's 8 of water. Okay. Not a big deal. We're gonna put some water in. 8 of water. Don't worry about the amounts. It's more important that you know what's going in here. So let's put 8 of water, W for water, sterile water. 1, T1, T2, T3. Always count so you know where you're going. T4, T5, same tip, doesn't matter. T6, because everything's blank still. T7, T8. All right, that's my water. Let's put the DNA in now. Whoopsie daisy, going too fast. Let's put the DNA in now. Now I have to change tips. So if you see me not change the tip, you can scream. Okay. So let's put the DNA in now. I just put water in here, just straight up sterile water. Now I'm gonna put the DNA in. I have to dial to 10. 10 of DNA. Again, don't worry too much about the amounts. They're about equal. I'm putting it on the side again. I'm gonna close that and close my U. Close my U. T3. I'm closing them so I know that I've done those already. That's pretty important. I am watching everything. I'm going fast, I realize that, but I'm watching everything I'm doing. I'm watching the volumes. It's really important to watch your volumes so you know that you're actually picking something up. Okay, so now I'm going to dial my pipetter down to 2. About 2-ish, a little over 2. And I'm going to open up these U's again. Now, if you guys remember, these U tubes, these uncut tubes, just have water and plasmid DNA. That's it. Water and the mini prep plasmid DNA. So I'm going to add some loading dye to them. The loading dye is pretty blue, xylene cyanol, glycerol, and bromophenol blue. We work with this for the gels, and that's why we're putting loading dye in it, because we're going to put this DNA in a gel so we can look at it. So let's add loading dye. Now the problem with this is that it's such a tiny amount, but the cool thing is I can use one tip if I'm careful. If I look around, I see an area on my YouTubes that has nothing on it. I'm just going to add a dot of 2 to each one. If I add a little less or a little more, it really doesn't matter because loading dye is so heavy that if it gets a little less, it really isn't a big deal. All right, good. That's my loading dye. I'll be right back. Let's do some magic now. Okay. So all these U tubes have water, plasmid DNA in roughly equal amounts, 10 and 8, and the loading dye. But we have to marry all 3 because there's a dot of loading dye, there's a dot of plasmid DNA, and a dot of water, right? 10, 10, 10, 8, and 2. So let's marry them all. Let's put them all in. And just pulse spin them. So the water, the DNA, the dye all go to the same area. All go to the bottom. We did this right if they're blue and they stop spinning. And they are. Nice. So I'm just going to rotate it, and they look nice and blue. All the volumes look pretty equal. I worked fast, but I think I did them all. Okay, good. They all look pretty good. It's 6, 7, 8. 6, 7, 8, 5. It should be 4, 3, 2, and 1. So our U tubes are done. Great. Each tube is blue, so it's ready to be loaded into a gel. It's water, DNA, and loading dye. All right. Wow, that was pretty good, pretty fast. So now we have 3 minutes, I see, to get our digests out. Let's put the mini prep tubes back where they belong. This is cataloged in the clone report sheet. So 13, let's double check. 14, 15, 16, 17, 18, 9. I'm just looking at the DNA. There's DNA in each one, and 20. So there's 40 left here. Because when we did the mini prep, we eluded 60 microliters. I just took 10 for digests, and I took 10 for uncut. 10 for U, 10 for D. 10 plus 10 is 20. 60 minus 20 is 40. So there's 40 remaining. I'm gonna give this to Rutgers. They're going to sequence this, and I'll talk next period about how we sequence DNA. They're going to sequence it. Actually, they pay for it, but nevertheless, they're going to sequence the remaining 40. And if you want to do any more experiments on this 40, you can. You'll have 30 left over because there's 40 in here, 10 for sequencing. That gives you 30 left over to do other things with, which we can talk about. All right, good. Here's our DNA. This is cataloged in the box. Seal it up. Here's our uncuts. Let's get ready. And let's get our digests. All right. I'll go get them. It's been just about 10 minutes. All right. So put my uncuts over here for a moment. Here's my cuts, my digests. This is T1 and this is T8. So these all look nice. They're all pulsed spin, so they all have the DNA and the enzyme mixture at the bottom. The enzyme has been cutting the insert out this whole time. Hopefully, that's what we want. Now, the PowerPoint says you body incubate these. I did not obviously body incubate them. Body incubation is kind of fun. That's something we do in class if we have people, but it's just me. And I could have done that, but it'd be awkward for me to put them on my abdomen and thorax. So I use the incubator because there's only 8 tubes. But if you see that body incubation, that's what it means. It's just we use our body heat to incubate. It works great, actually. I think it works better than the incubator because there's no air. There's just these things against skin. But this works pretty well usually. Okay, so let's add loading dot to all these. Again, same thing, loading dot. Here we go. Dot on the side. Dot on the side. Dot on the side. Dot for 4. Dot for 5. I'm adding 2.5. Dot for 6. Dot for 7. And a dot. 2.5 for 8. Let's close these up. They're clear. The dot of loading dots on the side. Let's just pulse spin them just to bring everything together and marry it. That's it. Just to bring them all together. Let's put them with their little friends, the U-tubes. So this is U-T1. This is U, the uncut for T8. Let's find T1. Look at that. Nice. There's the 8. Perfect. There's 8D. This should be 7D. 6. Oh, T1. That's weird. So, okay, it's T1D. T2D. See, it's nice and blue. You notice I can even, there's almost a separation. The blue's at the bottom. If I just shake it, it nicely mixes. That's what you want. 3D. 3D. T4D. T5, T6, digest D. And T5D. There we go. And that is our restriction digest. UD for T1, UD for T2, UD for T3, UD, UD, and UD. Uncut, digest. Uncut DNA, digest DNA. Both of which are ready to load into a gel, which we'll do next week. All right. Have a good day. I'm going to stop recording.